Hello everyone. Welcome to our channel I Can Learn. If you haven't seen our other videos, do check them as well. If you like them, then please give a thumbs up, share our videos and subscribe to our channel. Hello everyone. Today we shall be continuing with the topic atomic mass. This topic has also been discussed in our previous video. Do check that as well, and if you like our videos, then please give a thumbs up. In our previous video, we discussed that how it was more convenient to have atomic masses as whole numbers. Today, we shall be continuing with the same. Searching for various atomic mass units, scientists initially took 1/16th of the mass of an atom of naturally occurring oxygen as the unit. While searching for various units for atomic masses, initially scientists thought that it would be better to take 1/16th of the mass of an atom of naturally occurring oxygen as the unit. This was considered relevant due to two reasons. Oxygen reacted with large number of elements and formed compounds. This atomic mass unit gave masses of most of the elements as whole number. Considering 1/16th of the mass of an atom of naturally occurring oxygen was relevant because oxygen reacted with large number of elements and formed compounds, and it also gave masses of most of the elements as whole numbers. In 1961, for a universally accepted atomic mass unit, carbon-12 isotope was chosen as the standard reference for measuring atomic masses. Finally, in 1961, carbon-12 isotope was chosen as the standard reference for measuring atomic masses. One atomic mass unit is a mass unit equal to exactly 1/12 the mass of one atom of carbon-12. The relative atomic masses of all elements have been found with respect to an atom of carbon-12. Let us now discuss this better with the help of an example. Let us consider a fruit seller selling fruits without any standard weight with him. Let us consider a fruit seller who is just selling fruits and does not have any standard weights. He takes a watermelon and says, "This has a mass equal to 12 units." He considers a watermelon and says that this has a mass equal to 12 units, which could either be 12 watermelon units or 12 fruit mass units. He makes 12 equal pieces of the watermelon and finds the mass of each fruit he is selling relative to the mass of one piece of the watermelon. Now he sells his fruits by relative fruit mass unit. This example can be considered in understanding the definition of the atomic mass unit. Like in this case, as the fruit seller considers a watermelon and says that it has mass equal to 12 unit and takes it as a relative fruit mass unit. Similarly, we have atomic mass unit defined with reference to carbon-12 isotope. Similarly, the relative atomic mass of the atom of an element is defined as the average mass of the atom as compared to 1/12 of the mass of one carbon-12 atom. Here in this case, as the fruit seller does not have any standard weight and he makes 12 pieces of watermelon and finds the mass of each fruit he is selling relative to the mass of one piece. In a similar way, the relative atomic mass of an element is defined as the average mass of the atom as compared to the 1/12 the mass of one carbon-12 atom. Or in short, we can say that relative atomic masses are determined by taking carbon-12 isotope as a reference. Let us now discuss atomic masses of few elements. Hydrogen has an atomic mass of 1, carbon has an atomic mass of 12, nitrogen has an atomic mass of 14, oxygen has 16, sodium has 23, magnesium has 24, and sulfur has 32. Let us now discuss how do atoms exist. Atoms of most elements are not able to exist independently. Atoms form molecules and ions. These molecules or ions aggregate in large number to form the matter that we can feel, see or touch. It should be noted that atoms of most elements are not able to exist independently. Atoms form molecules and ions which aggregate in large number, as a result of which they form matter. Let us now discuss what is a molecule. A molecule is in general a group of two or more atoms that are chemically bonded together, that is, tightly held together by attractive forces. We just discussed that how atoms of most of the elements are not able to exist independently and they aggregate to form ions and molecules. Therefore, molecule is a group of two or more atoms which are chemically bonded together. That is, they are held together by attractive forces. A molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence. It should be noted that molecules can exist independently as opposed to atoms, which of most of the elements are not able to exist independently. Molecules also show all the properties of that substance. Atoms of the same element or of different elements can join together to form molecules. Let us now discuss molecules of elements. The molecules of an element are constituted by the same type of atoms. Same type of atoms, when aggregated together, form molecule of an element. Molecules of many elements such as argon, helium, etc. are made up of only one atom of that element. But this is not the case with most of the nonmetals. For example, a molecule of oxygen consists of two atoms of oxygen and hence is known as a diatomic molecule, that is O2. If three atoms of oxygen unite into a molecule instead of the usual two, we get ozone, which is O3. The number of atoms constituting a molecule is known as its atomicity. The number of atoms which combine to form a molecule is known as its atomicity. Metals and some other elements such as carbon do not have a simple structure but consist of a large and indefinite number of atoms bonded together. In case of metals and many other elements, the structure of the elements is very complicated and indefinite number of atoms are bonded together. That is it for our today's video. In our next video, we shall be discussing further on the same topic. If you like our video, then please give a thumbs up and subscribe to our channel. Thank you.